Hey there, day 22, just about to start. Thanks for hanging out with me this year doing these. Seem to be almost to the end. Okay. Grove is protected by a force field. At least you're pretty sure that's what these elements aren't exactly fluent in monkey. Okay. Let's give you notes that they took when they last saw the password you entered, your puzzle input. This is our, whoops. This is our puzzle input, huh? Okay. First half of the monkey's notes is a map of the board. It is comprised of a set of open tiles on which you can move, dots, solid walls, tiles you cannot enter, hashes. Second half is a description of the path you must follow. It consists of alternating numbers and letters. Number indicates the number of tiles to move in the direction you're facing. If you run into a wall, you stop moving forward and continue with the next instruction. Letter indicates you turn left or right. So a path like 10R5 means goes forward 10 tiles, then turn clockwise 90 degrees, and go forward 5 tiles. You begin the path in the leftmost open tile. On the top row of tiles, initially you are facing to the right. If a movement instruction would take you off the map, you wrap around to the other side of the board. In other words, if your next tile is off of the board, you should instead look in the direction opposite of your current facing as far as you can until you find the opposite edge of the board, then reappear there. For example, if you are at A, facing to the right, the tile in front of you is marked B. If you are at C and facing down, the tile in front of you is marked D. Possible for the next tile, after wrapping around, to be a wall. This still counts as there being a wall in front of you, so the movement stops. By drawing the last facing you had with an arrow in each tile you visit, this is the full path you end up taking. To finish providing a password to the device, you need to determine the numbers for your final row, column, and facing as your final position. Rows start from 1 at the top and count down. Rows start from 1 at the left and count right. Okay. Sure. Facing is 0 for the right, 1 for down, 2 for left, 3 for up. Final password is the sum of 1,000 times the row, 4 times the column, and the facing. In the above example, you end up 6, 8, and 0, so that's 60, 32. Following given pass, what is the final password? What does your puzzle input look like? Okay, that actually doesn't seem too bad. You can't really see all of that, so, but yeah, it doesn't seem too bad. There's a lot of instructions, but sure. So we know 10R5 means goes forward 10 tiles. So we have a couple of parsing things to do here, which is, I think in this case, yeah, all right. So let's start parsing. We don't want to kill the blank line. Actually, we can kill the blank line, that's fine, because the map is going to be everything but the last line. So instructions are going to be, let's see, data sub data length -1, right? And then the map is going to be, let's see, instructions through data length -1. I think that's correct. Let's take a breakpoint there. I'm not 100% sure on that one. All right, so those are our instructions, and then that's our map. That doesn't look right. That should be 0 to that, right? So let's go look at the map. Oh, that's data, not instructions. Hello. So that's our map, which looks like that. Actually, we wanted to, I guess you can do -2, it's fine. So we want to probably throw this into arrays, right? We'll do this, we'll do data select to array. That'll give us a 2-dimensional character array, right? I'm gonna put a to array on the end. That'll give us a 2-dimensional character array. Okay. So our first position is the leftmost. All right, so our position X is going to be the leftmost position. So the map sub 0, because I believe it's going to be YX, right? So map sub 0, index of, well, not really index of. We want to find the first non-space. Let's see, so position X will be 0, while position X is less than map 0 length. If position X, let's see, yeah, position X is equal to a space, then position X double plus, else break. I think that should be right? Yeah, so that'll be our starting position there, and then our position Y is of course going to be 0, and our direction is also going to be 0. So we decided direction-wise, 0 is right, 1 is down, 2 is left, 3 is up. Okay. So all that's fine. So our position here should be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 8, right? Why are we at 0? That's not what I expected. Map 0 length is 12. That makes sense. Those are 12 long. If position X is a space. If map sub 0 sub position X is a space. Okay, that's better. Well, that's going to put us at 8. Okay, good. So what we need to do then is we need to start peeling off instructions. So if, so we'll do this while true. Let's see, var, let's see. Yeah, it's fine. We'll manipulate the existing instructions, or we'll bring it down here. Actually, we can bring both of these down here, can't we? That's fine. Okay, so we need an instruction index. Instruction index will also be 0. So if instructions at instruction index is, let's see, this is going to be like, what is this? Char is ASCII letter. So if you're a letter, right, then we're going to pull you out. Direction equals this switch, right, this switch. If you're an R, then you're 0. Let's see, now if you're an R, then direction +1. If you're an L, your direction -1, right? Otherwise, throw new not implemented, or not, invalid operation is what I usually throw here. So that is correct, right? So if we go right and we turn right, that's down. We turn right from that's left. Okay, so that's good. So that's all right. Otherwise, what we need to do is here, and then by the way, instruction index goes 1 forward. So while instruction index is less than instructions length, otherwise we're going to try and do int try parse. So the question is, what does the try parse of something with a letter give me? And I don't actually know. So I'm going to just comment all this out for a moment. I'm going to say console right line int try parse 12R 24L out var number. Yeah, let's see what happens with that. So that's a false. Is there a variant of try parse that lets me say just read until you run out of digits? Probably not. So that means we need to find the end of the digits. Okay, so end index is going to start as the instruction index, and index is less than instructions length. And instructions, let's see, we do char is number of instructions at end index. We're going to do less than or equal. No, probably just less than. Double plus instructions index or end index, right? And then we're going to say number is int parse instructions of instructions index to the end index. What's the problem here? Okay, so you need to stay out there. So then we'll do this, and we'll move this down here then. All right, so that's a number, and then instruction index is equal to the end index. This will right line the number. Let's also console right line this. All right, let's make sure that we are parsing everybody correctly. 10R, 5L, 5R, 10L, 4R, 5L, 5. And the end is a 5. Okay. So that looks good. All right, so then given this, we need to move in a particular direction, right? So while number is greater than 0, we're going to do something, and then yes, that goes like that. We can do this as a 4. we're going to say pos x, pos y is get next position of pos x and pos y with the given map. Let's see, and the direction that we're supposed to be headed. All right, so that'll be like that. And then that should be all we need there. We just need to write this. All right, so that's going to be int pos x, int pos y. That's what we're going to return out of that. Let's move you up here. And what are you upset about? Can it implicitly convert blah to blah comma blah to int? Oh, do I have to write it like this? I probably have to write it like this. Yes, okay, so how do we know the next position? Well, we know the next position based on where we are, where we're going. Right, so potential, so result x is pos x, result y is pos y. If direction is 0, then result x double plus, else if direction is 1, 1 is down, so that's result y. Else if direction is 2, then result x double minus. Else if direction is 3, then we're going to say result y double minus. Then we're going to look at where we're at. So the first thing is if result x is greater than, let's see, map max, unless we want max x. So if we're going to put the map up here and pre-compute max x, then that means I don't need the map, which is fine. All right, max x is map 0 length, max y is map length. Okay, so if we've moved too far, we should be able to do this. All right, mod. Yeah, I don't want to do mods, actually. Mods of negatives are negatives, so I don't really like that. So if the result x is greater than max x, then result x is 0, minus equals max x. Same thing. If result x is less than 0, then result x plus equals max x. Result y is greater than max y. Result y is max, let's see, minus equals max y. If result y is less than 0, then result y plus equals max y. Then we've got to look in the direction, let's see, we've got to do the wrap. It's possible that what I should be doing is I'm gonna need to know what direction to wrap, so I'll move all these up here, which is fine. All right. So then the first thing we're going to say is, for example, if this is a wall, we'll do this. We'll say while map at pause, let's see, result y, result x is equal to a space. We're going to do that. And then we're going to say if map at result y, result x is a wall, then result x is position x, so we don't move. That's essentially what we have to do. That's going to be common all over, right? So if we hit a wall, then we can just do result y is position y. And then this will come down here with this. We just keep going. All right, and then we come down here with this, keep going backwards, come down here with this, and then we go backwards on the y. All right, and then we return result x, result y. I think that's all we need. So let's take a look at every time we hit this. Input string was in the wrong format. Say who and a what? What is this then? What is this? Well, that's interesting. Instructions index, end index. Oh yeah, can't do that until down here, of course. That was dumb. It's fine. All right, so we're going from 8, 0. We're going in the direction. Oh, we didn't do a distance, did we? Oh, the distance is handled down there, so that's fine. So we're going right. So we should be able to get to 9, 0, no problem. All right, so there's 9. So we get to 9, 0, no problem. We're going to go right again. We should be able to get to 10, 0, no problem. So there's 10, 0. And we're going right again. And now we should not be able to move, right? Because that's not an issue, but this is an issue. So we stay at 10. So if we were going to say pause x, pause y, direction, result x, result y. So we're still trying to move right. And we shouldn't be able to move right. So we don't. And we're still moving right. We can't. And now we're still moving right. We can't. We're still moving right. We can't. Was it 10? Yes, we're going to do this 10 times. Okay. Just waiting for direction to change here, right? So now direction is down. So that means that y is going to go up. So we're going to go to 10, 1, which is here. So that shouldn't be a problem. And we'll do map at result y, result x. All right, so that shouldn't be a problem. So now we're at 10, 1. And we're still going down. Let's put the breakpoint there. That'll be helpful. So we go down, yep, which means we're going to end up there. That's okay. So 10, 2. I really want to see us wrap. That's the last thing we haven't actually seen, right? And then we're going down, which will put us right there. So that'll be 10, 3. So that's okay. And we're still going down, so that'll put us at 10.4. That's okay, and our direction is still down, so we're going to 10.5, and that's okay. And then we're now going right. So that should put us at 11.5 right there, right? So that should be okay. And this is the wrap, right? Because now we're going right. That's going to lead us to yeah, this should have been greater than or equal to. Okay. It's fine. So 10, 0, and then we go down, we'll get to, I think, 15 or 10, 5. Is that right? 10, 5, and now we're going right. So that'll get us to 11, 5, which is fine. And then we're going right, so that hits that. So that puts us back at 0. And 0 is one of these, so that's okay. So we never hit that. So that's going to put us at 11, 0. Oh, sorry, 0, 5. 0, 5. Okay. And we're going right, so that'll put us at 1, 5. And then that'll put us at 2, 5 and 3, 5. And now we got to go down, which puts us at 3. So 0, 1, 2, 3. So that puts us at 3, 6. Okay, that's fine. Now we have 3, 6 down, should put us at 4, 6. Sorry, 3, 3, 7, my bad. 3, 7, and now we're trying to go down. So this should rotate us all the way through. This is the more interesting rotation, right? So that's going to put us at 8. And we don't have a rotation here. So we'll go away diagnostic tools. So we need the rotation logic in here as well. All right, and then the rotation logic goes in here. And then the rotation logic goes in here. Okay, so let's see where we end up. Right, we should end up. I think we're good now. So where do we end up? We end up at 7, 5, which is actually 8, 6 because they number everything plus 1, right? So we ended up at column 8, row 6. So it's 1,000 times y plus 1 plus 4 times x plus 1 plus the direction, which is 0. So we're going to return 1,000 times position y plus 1, right? Because that was 6 plus 4 times position x plus 1 plus the direction. So that should get us 6032, right? Okay, it does. Let's go get our real input. Let's go see what happens with our real input. We get 27610. Ugh. 27610, submit. That is not the right answer. Oh, that's interesting. That is not the right answer. So is there anything weird? I'm going to put input over here for the moment so I can look at the map. Is there anything weird about this map? don't see anything particularly strange about this map. Like there are no weird holes in it, right? Okay, so let's just double check all the logic then. You can go back to being over here. So let's go double check all of our logic. All right, so if we're going right, then we go up X. And we wrap. And while the result yx is a blank space, we go up and we wrap. And it's the exact same wrap logic. So down is plus, and if we're too big, we go back. And while we're in empty space, we go down, and if we're too big, we go back. Same thing, okay. So then left is x minus minus. When we're less than 0, we add, we go to the right, all the way around to the right. And then as long as we're a space, we go backwards. And if we go down off the edge on the left, then we go up or to the right, all the way to the right. That looks okay. And then we say up. And if we missed up, then we go up by y. All right, result x, max x, result x, max x, result y, max y, result y, max y. So we do minus and then we wrap again. And then if the result of all of this is that we hit a wall, then we just reset ourselves back. That logic looks correct. That logic looks correct. So is there anything weird about any of these numbers? I think if I was having an in-parse problem, it would throw, right? "23 right, 40 right, 49 left, 35 right." So one of the things we could do is leave a mark, right? And then print the map every time. So every time we move, I'm going to go back to the old data. I just want to make sure that when we print the map, it looks exactly like we expect. We never actually look for dots. We only look for spaces and hashes, right? So map at pos x, pos y is equal to direction to char of the direction, right? And then char, direction to char, and direction. And that is return direction switch. 0 is this, right? 1 is this. 2 is this. 3 is this. And then this is throw new invalid operation. Oh, you know what? I already know what happened. But I'm going to watch it happen. We're gonna end up here because we have a direction of 4 or a direction of -1 because I didn't wrap that stuff correctly. Guarantee that's what happened. So that one worked okay. 2036, 2036. Should have been 6032. Wait, what? 2036. Huh. That's weird. Print map, map, print map, console read line. All right, so let's get a print map in here, void print map. Just going to be for each var row in map, console right line the row. I think that should work, right? Let's see what happens here. Right. Oh, that's in the right. That's in the wrong place. Yes. Pause Y and pause X. All right. Yes. 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 And then that's where we ended up. 6032. Okay. So I believe that my direction change if direction is less than 0, let's see, if direction is -1, then direction is 3. Else if direction is 4, then direction is 0. So I think without this, with the real data, we're going to see an invalid operation. Oh yeah, no, I don't want to print. I actually want to get rid of the print. I don't need to print. I just want to record everybody. All right, you'll come down here. You can get commented out. Yeah, so we got an invalid operation, and that's because we wrapped on the directions. That's why I got a bad number. So I put that in there. Now we've got an index outside the bounds of the array. That's not expected. 78. Okay. So what is result y? It's 199. Result x is 64. What is max x and max y? So those are okay. Okay, well, what is map 199? That's okay. Map 199, 64. Why is that out of range? Oh, you know why? Because I trimmed. Oh, yeah, because I trimmed. Yeah, okay. Let's not do the trim. Oh, you know why? I didn't. Oh, that's awful. Yeah, that's because the data is already trimmed by whatever this is. So, so one of the things I could do is instead of comparing against max x, or yeah, this max x is the problem, right? Which is if I do map result y length, if you're greater than that, then you'll just be 0. I don't know why I wanted to make that more complicated than it has to be. It doesn't have to be any more complicated than that. Max y is already correct. So if result x, then result x is map result y dot length. Yeah. Okay. That should be fine. Now when we run, oh, we still got an index outside of the bounds of the array. So result x, result y. So here we are again. Okay. I think in these cases, what I need to do is to say if result x is greater than or equal to map result y length, right? So we're off the edge, so that we don't even try and read it. And that should only happen in the y cases. think. 190066. Let's see if that's our answer. 066. Okay, next part. Let's see. As you reach the force field, you think you hear some elves in the distance. Perhaps you've already arrived. You approach the strange input device, but it isn't quite what the monkeys drew in their notes. Instead, you're met with a large cube. Each of its 6 faces is a square of 50 by 50 tiles. To be fair, the monkeys map did have 6 50 by 50 regions on it. If you were to carefully fold the map, you should be able to shape it into a cube. You still start in the same position and now with the same facing as before, but the wrapping rules are different. Now, if you would walk off the board, you instead proceed around the cube. But from the perspective of the map, this can look a little strange. Okay, so walls still block your path even if they're on a different face of the cube. If you are at E facing up, and your movement is blocked by the wall marked by the arrow. Using the same method of drawing the last facing you had with the arrow at each tile, the full path taken, the final password is still calculated from your final position. So that's the same math, it's just we now have to treat it like a cube. Yeah, that sucks. So our data here is yeah, 50 by 50 cube. Although this data was not a 50 by 50 cube. This data was a 4 by 4 cube, right? So what we need to know, first of all, is what is the cube size? Right, because that length is probably that length is 12. The height is 12. Height is 12. Okay. And then the real input, so it's actually 150 by 200. Well, let's shortcut it. Side size is definitely 4, right? So the side size is 4. And we haven't done anything with the map yet other than we haven't done anything with the map other than recording our directions, which we don't have to do. Which, this move is the part 1 move. So you can get stuck in there, and we'll go move. And actually, you guys can now take these. You don't have to take those as input anymore. All right. And we're not going to record or print. Okay, let's make sure that we haven't totally killed everything yet here. 190066, so that was correct. And 6032, that one's correct. Okay. So the side size is 4 or 50. I actually I'm actually okay even hard coding knowledge of the problem, right? So we can say sides. So if we were going to draw this as a cube, we could basically arrange the sides so that we know which side goes off of which edge, right? So our cube is 1 goes down to 2, which goes down to 3, which goes down to 4, right? Which then means if that's 1, 2, 3, 4, so then 1's left, we'll call 1 left to 5. Let's see, let's do this. 1, yeah. So down is 2, left is something, right is something. All right, this is what we have to figure out. Two, 3, 4, 5, 6. Although let's do 0, 1, 2, 3, 4, 5. All right, so if we're going to say 1 down 2, 0 down 1, 1 down 2, 2 down 3, 3 down 4. Right, 4 down goes back to 0. No, yeah, 4 down goes back to 0. Wait a minute, 0 goes down to 1, 1 goes down to 2, 2 goes down to 3 goes down to 0. That's what I meant. And then we have to figure out where 4 and 5 are. So 4 can be, if we're on 0, then we'll say falling off the left of 0 will send you to 4, which means the right will send you to 5. Okay, so now if we're on 1, actually that shouldn't be a problem, right? I think. So if I look at this, if I look at my input here, like let's call this 0, right? Which means we're going to call this, so that's 1, which means that's 4, and that's 5. So this is, except that can't be right. No, this has to be 4. But we also have to make sure that we get them in the correct ordering. Like we have to know where the, like what edge goes to which. Right, so this, so if I was going to say the sides, this is going to be a new, let's say the left edge is going to be of this would be 8. All right, and the top edge would be 0. So new int left, int top. We need top and left, and then down add, and then right add. Okay, so what that means is this would be at 8, 0, and down and right are both 1. All right? So that's the 0th face. That's this face. So that's this face. So that means 1 is here. So that would be so 1 then would be at 8, 4, and also in the same direction, right? And then 2 ends up at 8, 8, and again in the same direction, 8, 8. And then, so this is 1, and then left means this way from 1, that's going to be 4, right? Because I'm pretty sure these are just going to be 4 and 5 for all of these. For all of these. So going left means 4. So that puts 4 at, let's call it, it is 4, 4, right? 4, 4. Now this wraps around the back. This wraps around the back. And that becomes 3. That was 4. So 3 wraps around the back. And you're going to be at, let's see, you're going to be at 3, right? Because I want you right here. So you're going to be at 3, 4. And your down is still down, but your right is backwards. And then the last one is this one, right? And so I think that just means that you're, all right, so if I was in 1, let's say 0, 1, 2. So if I wrap you around this way, I think because, oh, man, I don't know if I'm visualizing this right. I kind of want to build it. Like I want to physically build it. All right, give me a second. I'm going to go grab a piece of paper. Okay, it's definitely good that I drew this. I'm going to give you the bigger picture here. Right? So this is the cube, 0, 1, 2, 3, 4, 5, right? So when I fold it up, what you see happening here is we'll start, well, 0 is kind of tough to tell, but this is 0 on top, right? And so then this is 1. So if I'm to flip over to 2, right, that's okay. But then if I flip over to 3, you can see 3 is completely upside down now, right? And so same thing, if I start at 0, right, and then flip over, I need to flip over to 5, right? 5 is sideways. 5 is sideways. Same thing with 4 looks okay. Yeah, 4 looks okay from the perspective of 1. 4 looks okay. But from the perspective of 0, I'm trying to get my fingers out of the way here. 4 looks sideways. So I have to figure out what is the best way to represent this. What is the best way to represent this? So if I want to go from, so what if, well, we know the side size, right? So we know where the extents of everybody are. And so if I want to go, it's like I need to know how to bridge from each side to each side. I don't, this feels like this should be a solved problem, right? This feels like this should be a solved problem. Represent cube in C#. Cube, let's see, cube data structure, surface traversal, marching cube algorithm, comparative study, marching cubes, solves 5 tasks to extract a surface from volume data, determine the case edge of each cell, determination of the intersected edges, computation of intersections by means of linear interpolation, triangulation of the intersections, and computation. After the case index for the cell is determined, the cell edges are intersected by the iso surface can be looked up in the case table. In figure 6.6 on the right, 6 cell edges are intersected by the iso surface. That is not what I'm looking for. What if I were to set up the notion of yeah, there's got to be represent cube with 2D array. How to construct a cube representation of a Rubik's Cube given an array. I've seen this and it's not what I'm looking for. How to represent a okay, if I'm just a cube state in memory with X number of tiles per side. Cube can be if it's a Rubik's Cube, so there's going to be rotated. plain old array of 6x times x. You do not need to know the inner mini cubes because you do not see them. They are part. Hide two ugly methods behind a nice looking one and simple to use interface. Unit test to death, voila, you're done. Should be known that I'm an avid speed cuber, but I've never tried to, okay. So a cube. Found an XYZ coordinate system to be a simple way of addressing and rotation matrices in a simple generic way. Create a piece class containing a position vector. A piece can be rotated by applying a rotation matrix to its position. I actually don't care about the rotation part. I just want the data representation. In addition to 6 3x3 arrays containing the colors, you could have a 3x3x3 array representing the solid cubes. Interior cell of this array can be ignored. The cells of the 3x3x3 could then contain integers or pointers to more detailed objects describing the original location. That's not actually what I care about either. Address cube in an XYZ coordinate system with a center at 0, 0. What's interesting is I still need to know, like I'm almost positive that I still need to know where I end up with in terms of the final row and the final column, right? What if I just were to say, given this data structure, right? What if I represented the empty spaces, right? What if I represented the empty spaces like this and said, for each empty space, there is an appropriate place in the matrix that is that empty space, right? So in the case of my drawing here, which is an accurate drawing, right? So if I was to go from 0 to 4, right? So now looking at this, if I fold 0 to 4, right? The empty space is to the left of the empty spaces to the left of 0, right? End up along the edge of 4. So like this empty space, so this empty space right here maps to this empty space right here. So let's do this. Let's do the empty space maps. Forget about this. Empty space maps is a dictionary of XY to the new XY that you should actually be going to given that position. So the left edge of 0 in our input, let's put our input off to the side again so that we can get a better visualization of this. All right, so the left edge here, right, so that is position 7, so 7x and 0y, right, so I'll say for and x is, well, y is 0, y is less than 4, double plus y. We're going to put an empty space map for empty space maps add. The x is 7 and the y will map to, so this one ends up right here, right? So that is, I kind of need this to be over here so I can see my I can see my lining character, right? So this is here, right? This goes here. Well, here, which would be so the x is going to increase as the y increases. So this is going to be 4 plus y, and then the x, and then the y stays at 3, right? So that's this edge. So then this edge, which puts us at 12. So y is 12. Y, so sorry, y is still 0. Y is less than 4. Double plus y. We add an empty space map, which then goes from, so given the way this all folds up, that's 5. That's the right-hand side of 0 maps to the right-hand side of 5 upside down. Maps to the right-hand side of 5 upside down. So that means that 0y, so let's see, so this is 13, right? 13y ends up at, let's see, so your x is going to be 0, 4, 8, 12. 12 plus y. No, it's upside down, so it's the right-hand edge. So it's the right-hand edge. And the top goes to the bottom. So the x is fixed at 15. What is this? 17. The x is fixed at 17. And then the y is upside down. So 0 is going to be this y, which is 11. So 11 minus y. So that's those two edges. Now we need this edge. Okay, so now we're going to run along x. So let's actually, right, so we're going to do 4. X is less than 8, double plus x. We're going to add space map that goes from, let's see, so if I'm coming off of this edge, I'm coming off of the top, then I go along the left edge of 0. So at x, and the y here is 4. That's going to map to so 4, 0 is going to map to the x over here is, so those edges run in the same direction. So the x over here is 8, right? 8 plus x with a y of, sorry, no, just 8 with a y of, so 0 maps to 4, so 0 maps to 4, so that's x minus 4 because 1 then maps to 5. Yep, okay, so that's good. We need to do the same thing now for what the edge we call 3. We have 3 things to map off of this. We need to map the top, the left, and the bottom. So let's see. So this is 0 top. No, this is 0 left. Right. We also need 0 top, and we need 0 right. And then, so what was this 0 right? Y is 0. 1, 2, 3, 4. So that all mapped to 5. Yeah, so this was 0 right already. We don't have 0 top yet. This is 4 top. All right, so let's do 3 top. Then we're going to need 3 left. We're going to need 3 bottom. We're going to need 4 bottom. All right, we're going to need 2 left. We're going to need 2 bottom. We're going to need 5 bottom. We're going to need 5 right and 5 top. Okay, so let's arrange these. And 1, we also need 1 to the right. So that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sides. So there's 2, and then we'll move 3 up here. And then this was, sorry, we said this was 0, right? My bad. All right, so 3 along the top means we go from x0 to x4. Those all go to 0 along the top, but in reverse order. So given, all right, so we're going to do x, and the y for this is 4. You're going here, which is you map along the top of x in reverse. Top of x in reverse. And so that's going to be, the y is 0, and this is 4 minus x. Mm, 3 minus x. 3 minus x. Because 0 goes to 3, 1 goes to 2, 2 goes to 1, 3 goes to 0. So 3 minus x. All right. So what is 0 on the top? So 0 on the top is exactly what we just did, except in reverse. So I think what that means is we need to do this, which is we always need to add them in reverse order as well, right? Because we go backwards as well. Okay, so 0 left to, that means, so 0 left goes to 4 top. Isn't that interesting? 0 left goes to 4 top. So then how come, why did we do this like this and not have these be exactly the same? Oh, these are not exactly right either. Damn it. Because we want them to come off the edge, right? So 0 left, we're using 7 on the x to indicate we've fallen off the edge. But coming off of the top of 4, we need to use, yeah, that's funny. 3 on the y does make sense, but it really doesn't, like that should have been 4 over here, right? No. 0, 1, 2, 3. No, yeah, that should have been 4. And then that should be 8, right? Because, so this, which is 7, 0, right? So that's 7, 0 goes to here, right? And that is 4, 4, which then means when we come off the top, then that means 4, 3, which is also equal to 4, 3, then maps to back to here, right? Which would be 8, 0. So is that what we're doing with both of these? So there's 7, 0, and then when y is 0, that's 4, 4. And so then we also have 4, 3 to 8, 0. So yes, that is exactly what we're doing. Okay, so this is wrong, but close, right? So if we're doing 3 top to 0 top, which makes sense, let's actually write it as 0 top to 3 top, right? So that means that we have 8, -1 goes to 8, -1, 8, -1 drops into the y at 3x. So it drops into the y at 3x. And then the y would be 4, right? And then the opposite side, when we come off of the top of 3, right? So that would be 0, 0, 3, right? That, at the top of that, that would go to, looks like, let's see, 0, 3 goes to, looks like 12x and 0y. Right, so this is, so then this goes like this. So 8, how do we get to 8x and a -1? Right, so if we're gonna go up in the x direction, no, we're not gonna move. So we're going top, we're moving y. This is the problem, right? No, we're going at x. No, I'm right, I was wrong. So x starts at 8, x is less than 12, right? So here we have x, so for every x with a -1, we get a, we're going backwards along the top. So it should be 3 minus x. 3 minus x minus 8, which I suppose I could solve that elsewhere, but whatever. All right, so and then the y is just straight up 4. So that gets us 8, -1, and then this is 3, because x minus 8 is 0, so 3, and then that goes backwards. So in the other direction, we fall off the y edge of 3 going up, right? And so this is x minus 8. That gets us to 0. And then that goes backwards. So if we fall off the top edge, then that means we have 12 minus, we should have 12 minus x minus 8. And then that is y of 0. Okay. So we now need 0 right goes to 5 right. 0 right to 5 right. So in order to come off the right-hand side, we're going to do y is I kind of want to simplify this. I know this is dumb to try and do this, but I'm going to subtract 8 everywhere. All right, give me that. Okay, so this should have been plus 8, -1, and then that goes to 3 minus x. So that'll go 3, 2, 1, 0, and then that's fixed. So this is like 8 to 12 to -1 is 3 to 0 on 4, right? And then 0 to 4 on 3 goes to 12 to 9. 12 to 9, comma 0. All right, that math is starting to make more sense to me. I kind of want to put these back here like this. So this is going to be coming off the left, we are always at 7. So 7 to 0 to 4 gets mapped to, should be 7 to 0 to 4 should be on the x should be 7 to 4, and the y is always at 4, right? Oops. And then the other direction is we've got 4 to 7, comma 3 gets mapped into 8, comma 0 to 4. That's what we've got right now. Let's see if that actually makes sense. So 4 to 7 on the y, except no, that's 4 to 7 on the x. Okay, yeah, right. 4 to 7 on the x maps to 8x always. Yep. And then the 3, the y side maps as we go along here, we go along here. So yep, that goes like that. Okay, I'm feeling good about that now. Okay, 0 right to 5 right. So the right means we're doing y's, right? And what it looks like is, so from an x perspective, x is always, looks like 0, 4, 8, 12, right? So 12, 12 comma y maps inverted along the right side. So 12 comma y, which would be 12, 0 to 4, right? Maps to the right-hand edge. So the y will be what's moving. The x is fixed at 15. And then that should be, from a y perspective, 0, 4, 8. So that should be 11 to 8. And then the other direction, coming off the right-hand side of 5, that would be an x of 16. And then the y's will be from 0, 4, 8 to 11. That will be mapped to a fixed x of 11, right? And then that'll be 3 to 0 because it gets mapped in reverse, 3 to 0. Okay, so we do empty space maps add. All right, so this is 12, and then this is y, and then this is 15, and then this is 11 minus y. And then we do space map add from 16 to y plus 8, right? Gets mapped into 11 and then 3 minus y. So that all looks okay. So we've now done all the sides of 0. We have not done the right-hand side of 1 yet. So 1 right goes to 5 top. It's to 5 top. So this is going to move along the y-axis again because it's right. Okay. So then this is exactly the same as this, except this is now, well, this should be 0 to 3. Shouldn't have been 0 to 4. Should have been 0 to 4. Should be 8 to 11. 3 to 0, 12 to 9, right? The differences should always be 3 here. 0 to 3. Okay, so this is now, this is not, so this is 4 to 7, right? And then the top of this then goes, it goes backwards, looks like. So then that would be, from an x perspective, that is 0, 4, 8, 12, so 15 to 12 with a fixed y of 0, 4, 8, with a fixed y of 8. And then the opposite side, coming off the north side of 5, that means we have a fixed y of 7, sorry, because we're coming off of the north side. Man, this is really going to be a test of whether I got all my math right or not. Yeah, I'm going to have to double check everything. So coming off the top side, this is going to be, right, and the x goes from 0, 4, 8. So it's 12 to 15 on 7. So that goes in reverse, right? So then that goes a fixed x of 0, 4, 8, 11. Yeah, 11. And then we go from, let's see, the y would be 4, 8, would be also be 11. 0, 4, no, the y would be 7 to 4, right? It's going to help me if I just sort of write some things down on this, isn't it? All right, I kind of want to draw this again, just not cut it out. All right, so this is let's see, 0, 4, this is 8, 0, this is 11, 0, this is 8, 3, so that's 11, 3. So then that makes 8, 4, and 11, 4, and 11, whoops, 8. Sorry, this is then 8, 7 to 11, 7, right? And then that makes this 12, 4, and 12, 7. So this is 12, 7. And then this is 8, so this is still 8. This is 8, 8 to 8, 11, right? And then this would be 8, 12. This would be 7, 11. This would be 11, 11. So this would then be 11, 12. And this would be 12, 12. So that's 12, 12. That's 12, 11. All right, so that's 12, 11. And then that's 15, 11. And then that's going to be 15, 12. And that's going to be 16, 11. And then this is 11, 8. Which means this is 12, 8. This is 12, 11, and that's 12, 12. So if that's 12, 7 there, then that means that is, wait a minute, that's, sorry, that's 15, 11. 15, 8. If I do this right. 15, 8, so that would be 16, 8. So that would be 15, 7. Okay, so if this is 4, 4, and then that would be 7, 4, that would be 3, 4, that would be 0, 4. So then this would be 0, 3. This would be negative 1, 4. This would be negative 1, 7, because that's 0, 7. That's 3, 7, which makes this 0, 8, which makes this 4, 7, which makes this, no, that's right, this is wrong. This is 3, 8, 3, 8, because that is 4, 7, and that is 7, 7, which makes this 7, 8. And then this is 4, 8. And then this is 3, 3. And this is 4, 3. And this is 7, 3. This is 8, 0. And this is 11, 0. Which makes this 8, negative 1. And 11, negative 1. and 7, 0, and 12, 0, and 12, 3. All right, I think I got them all mapped. I will use that to double check my math when I'm done. All right, so 1 on the right, right? So 1 on the right helps me to write all these in the middle. So, whoops. 0, 1, 2, 3, whoops, 3, 4, 5. Okay, so if I'm going 1 on the right, that means 12, 4 to 12, 7. That's what I've got. And then that's going to go to 5 top, which means it's 15, 7 to 12, 7. Or 15, 8 to 12, 8. Okay, that's what I've got. And then coming off the other side, that means 12 to 15, 7 is going to be 11, 7 to 4. Okay, that looks good. I'm actually having to write that down. That's like ridiculous, but you know, I'm sure there's a way to do this. I just don't know what it is. And then this is 15 minus y, comma 8, right? And then we add 12 plus y, comma 7 to 11, whoops, to 11 with 7 minus y. Okay, that looks okay. So now we've got that. So we've got all 3 sides of 0, the only one side of 1. We haven't seen 2 yet, so we've got 2 left. 2 left maps to 2 left maps to 4 bottom. We've also got 2 bottom maps to 3 bottom. Okay, so then that's all of 0, 1, and 2. So now, does that mean we got all of 3, 4, and 5? We've got 3 top and we've got 3 bottom, so we need 3 left. All right, so 3 left gets mapped to 5 bottom. 5 bottom. So that's all the 3s. Did we get all the 4s? We got 4 bottom and 4 top. We did. And then that should be all the 5s, right? 5 right, 5 top, 5 bottom. Okay, good. Everything else here can go away. All right, so if we're coming off of the left of 2, that means we are increasing in y. And so that also means coming off the left of 2 is 7, 8 to 11 gets mapped to the bottom of 4 in reverse. The bottom of 4 in reverse. So the bottom of 4 in reverse would be, looks like 7 to 4, comma 7. And then the opposite coming off of the bottom of 4 would be 4 to 7, comma 8. Right? Would get mapped to the left-hand side of 2. So coming off of that, it goes, it comes to the left-hand side of 2 in reverse. So the left-hand side of 2 in reverse would be 11 to 8, comma 11. Okay, empty spaces, space maps add. So then this is 7, comma 8 plus y to 7 minus y, comma 7. right? And then we do this again, which is y plus 4, comma 8 goes to 11 minus y, comma 11. Okay, so because we're coming along the bottom, that means we're going to go along the x-axis. And then, so 2 across the bottom. So 2 across the bottom is going to be 8 to 11, comma 12 gets mapped to 11, comma 12 gets mapped to you get mapped to what? It's the bottom of 3. The bottom of 3 in reverse. And so that is 3 to 0, comma 8. 3 to 0, comma 8. And then the bottom of 3 would be 0 to 3, comma 7 gets mapped to, whoops, no. This is 7 and this is 8. That's going to get mapped to, all right, because we come off the bottom. That gets mapped to the bottom of 2. So the bottom of, wait a minute, the bottom of 3. I did this wrong, right? Bottom of 3 is what I meant. Did I map this wrong? So 0 to 3, comma 7, 3 to 0, comma 7, that was fine. So 0 to 3, comma 8, right? No, I did that right. Is going to map the bottom of 2, but in reverse. So the bottom of 2 in reverse would be 11 to 8, comma 11. This is wrong. That can't be right. That can't be right. Because so what's happening here is like you need one side to come off the edge and one side to be inside the edge. I'm going to have to go back and revalidate all these. That's okay though. I'll get it. Empty space maps, add x plus 8, comma 12 to 3 minus x, comma 7. All right, and then we've got empty space maps, add x, comma 8 to 11 minus x, comma 11. Okay. And then 3 left to 5 bottom. So coming off the left, we'll use y's. It doesn't actually matter at this point because they get used interchangeably, but whatever. So 3 left to 5 bottom. So coming off the left of 3 to the bottom of 5, it's in reverse. It's in reverse. So coming off the left of 3 would be -1, comma 0 to 7. Right, it's going to get mapped to the bottom of 5 in reverse. So that would be 15 to 12, comma 11. And then coming off the bottom of this would be 12 to 15, comma 12 gets mapped to 3 to 0, comma 7. How could that be 0 to 7? It has to be 0 to 3. Wait a minute, it's coming off the left edge. Is that what I said? The left. That was my bad. So the left edge is 0, comma 4 to 7. But this, -1, comma 0 to 7, -1, comma 4, that should be 4 to 7. not 0 to 7. Okay, that all looks okay. All right, empty space maps add. So this would be -1 to y plus 4 goes to 15 minus y comma 11. And then we empty space maps add again. This is 12 plus y comma 12 goes to 0, whoops, goes to 0 comma 4 plus y. Yes, I know. I parenthesized wrong. Okay, let's make sure these numbers are right again. Okay, so coming off at the left of 0 would be 7 comma 0 to 3. It is. And we're going to the top of 4. We're going to the top of 4 in the forward direction. Top of 4 in the forward direction. So that would be 4 to 7 comma 4. So that's wrong. 4 to 7 comma 4. And then coming off of the top, that means 4 to 7 comma 3 gets mapped to 8 to 0 comma 3. Okay, so 7y. I'm going to stop using y. I'm going to start using I instead. And then 8 comma I. So this is 4 plus I comma 4. This is 7. All right, and then this is 4 to 7 comma 3, and this is 8 to I. Okay. So then 0 top to 3 top, 0 top to 3 top. That one goes in reverse. So coming off the top of 0 would be 8 -1 to 11 -1. And then the reverse of 3 top would be 3 to 0 comma 4. And then coming off the top would be 0 to 3 comma 3. And that would go in reverse for the top of 0, which would be 11 to 8 comma 0. So that's 11, whoa, that's 11 to 8. So that's 11 to 8 comma 0. And that's 8 to 11 -1 to 3 to 0, 4. That is 0 to 3, 3 to 11 to 8, 0. Okay, good. 0 right to 5 right. 0 right to 5 right. That is in reverse. So that means 12, 0 to 3 goes to 15 comma 11 to 8. So that was good. And then the other side would be 16, 8 to 11 goes in reverse again against the top of 0. So that would be 11 to 8 comma 0. Wait a minute. Sorry, this goes to the right. 5 right. 5 right. So that would be 16 comma 8 to 11. Okay, good. Goes to 0 right in reverse. So that would be 11 comma 3 to 0. Okay, so that's good. So 12 I, right? 12I goes to 15, 11 minus I, and then that's 16I plus 8. That's 11, that's 3 minus I. Okay, good. Now we've got 12, 4 to 7. So one right to 5 top. 1 right to 5 top. That goes in reverse. Okay. So 1 right is 12 comma 4 to 7. And then 5 top in reverse would be 15 to 12 comma 8. Okay, good. Then we go 12 to 15 comma 8, or comma 7, because we're coming off of the top of 5. That gets mapped to to 1 right, which in reverse, which would be 11 comma 7 to 4. So that's 12 I plus 4 to 15 minus I comma 8. That looks good. 12 plus I comma 7 to 11 comma 7 minus I. That looks good. And then from here on out, I'm pretty sure we did the right thing, but we're gonna double check one last time. So 12 left to 4 bottom, or sorry, 2 left to 4 bottom. So 2 left to 4 bottom goes in reverse. So 2 left to 4 bottom. So 2 left would be 7 comma 8 to 11. And that's going to go 4 to 7 comma 7. So that's good. And it's reversed, so it's 7 to 4 comma 7. So then 4 to 7 comma 8 goes to 8 comma, wait a minute, 4 bottom, 2 bottom would be, sorry, yeah, 11 to 8 comma 11, right? Okay, good. So 7, 8, 8 I, 7 minus I comma 7. So I plus 4 comma 8 is 11 minus I comma 11. So that's good. And then lastly, we have, well, not last, second to last. We have 2 bottom to 3 bottom. So 2 bottom to 3 bottom is definitely in reverse. So 2 bottom is 8 to 11 comma 12. All right, and then that gets mapped to 3 to 0 comma 7. It does. So then coming off the bottom then, it'd be 0 to 3 comma 8. Would get mapped to 11 to 8 comma 11. It does. So I plus 8, 12, 3 minus I, 7, I comma 8, 11 minus I comma 11. That's good. And then lastly, 3 left to 5 bottom. So 3 left to 5 bottom. I can't believe I'm going to have to do this again, but I now have the pattern. I know what I need to do to make it work. All right, so 3 left to 5 bottom is reverse. Okay, so 3 left would be -1 comma 4 to 7. And 5 bottom would be, in reverse, would be 15 to 12 comma 11. Okay, good. And then we've got 12 to 15 comma 12, and then 3 left in reverse would be 0 comma 7 to 4. And that's supposed to be reversed. So that's 0 comma 7 to 4, right? Because that's reversed. So this is 7 minus y. Okay, so given these empty spaces, what do they show us here? Using the same method of drawing, the last facing you had an arrow with each tile visit looks like this. Okay, well, we should now be able to walk, except the walking is now different, right? So let's get our walk function, our move function, really. Sure, we'll do the move, and then we'll do the return. Okay, so what changes here is the way we move, right? What we do is we do this, and then we don't have to do any of this anymore. We just do this. Then we don't have to do this anymore, because then we do this. All right, and then we do this. And instead of that other stuff, what we do is we say, if empty space maps contains result x, result y, I will do try get value of result x, result y, comma, out var next space. So if we have one of those, right, then what that means is result x is result, we say result x, result y is the next space, right? And if that's a rock, then we just go back. This time we're going to print again. So we get the first place, we get our directions, we get our moves, and then we go. All right, let's see what happens, if it even compiles. Item with the same key has already been added, 7.3. Item with the same, it's going to be here. It's interesting. 7.3 is there. Where else is 7.3? I guess 7.3 is here. How could that be though? That can't be right, right? So 0 top goes to 4 top. 0 left goes to 4 top. Yeah, that has to be wrong. It's in the forward direction, right? So 0 left is, oh yeah, these have to be 4. Those are 4. So coming off of the left, we're 7, 0 to 3, right? Yeah, that's a good point though. It's like coming off the top, there's definitely overlap. So if I were to do empty space maps add, I have to do this as a regex, right? So empty space maps add. Zero dot star, comma, and we capture that, and then we've got that and that. All right, so we need to capture that, which is this and this and this. All right. So that's going to be empty space maps sub $1 is equal to $2 semicolon. Okay, that looks okay. Doesn't look totally destructive. Okay, so there we go. Let's move you over here and then come take a look at this because we're going to walk again, right? There's our complete walk. So we've got that, 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 we've got that. All right, so now we're down. We got the right, we end up over there, but with a right and a right, and that seems wrong. Where's print? We're also going to do a screen clear on print. Where's print? Print. Console clear. What we want to know when we print this map is All right, part one, just collapse. So you do 10 right, 5 left. So we're gonna do position X, position Y with direction right? Let's do this out here. All right. New direction. Direction to char of our direction. So that's where we are. And we do the print map. That's fine. Here we're going to do console clear. We're going to say console right line. Moving. Spaces. Spaces. Spaces is that. So we're going to do that. Then we're going to print the map. And we're going to read line. And then we're going to say here, let's see, var old x is pos x, old y is pos y. We're going to do this. We're going to say if pos x is equal to old x and pos y is equal to old y. All right, so you'll go up there, you'll say blocked moving that. Otherwise, we're going to say right line moved from old x, old y to, whoops, old x, old y to pos x, pos y, right? And then we're going to print the map and we're going to console read line. Okay, so watch every single step now. Okay, so the first answer is we're going to move right 10 spaces. We need to know where we are. So from pos x, comma, pos y, moving that many spaces. Print the map, pos x, pos y. Let's do that. Let's say at pos x, pos y, we're going to say for y is equal to 0, y is less than map length, double plus y. For int x is 0, x is less than map sub y length, double plus x. If x is equal to pos x and y is equal to pos y, we're going to do console write and at. That's where we are. Otherwise, you're going to console write map yx. And then after each one of those, we need a console write line. So we need pos x and pos y. All right, so print map pos x, pos y. We have more print maps in here, right? We have a print map here. We have a print map here. We have a print map here. What is this one up here? Oh, that's our move. We're not gonna print there. Right? We're just gonna, okay. So from 8, 0, we're gonna move right 10 spaces. So then we've got there, 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 we've got there. So from 10, 0, moving down 5 spaces. So we've got that, got that, got that, we've got that, and we're there. So we want 1, 2, 3, 4, 5. So that's where we are. 10, 5 with a new direction. Which, by the way, that was a correct way to come off of that face, right? So we're there. We moved from 10, 5 to 11, 5. We're going to have moved from 11, 5 to 14, 8. So if we knew what 12, 5, where 12, 5 is, 12, 5 to 14, 8. 12, 5 to 14, 8. Yep, that seems right. Okay. Oh, except we don't want to move right there anymore. We also need to have a transformation of what each direction means. Right. So yeah, we need a transformation. That's the problem. So all this stuff is a dictionary from that to int direction change, right? So 4 left to 0 top. Sorry, 0 left to 4 top. So if you were going left, you're now going down. So left to down would be a -1, right? So left to down would be a -1. That means we have to return direction out of this as well, which is fine. So left to down, where's our 0, 1, 2, 3? So left to down is a -1. And if you were going up, you're now going right. So that should be a +1. Because if you were going up, you're now going right. If you were going up, you're now going right. So that actually is a +1. Yep. Okay. So 0 top to 3 top. So 0 top to 3 top. If you were going up, now you're going down. I don't think it really matters because it's 2, so it's not going to matter all that much. But if you were going up, you go down, that's -2. If you're going down, then you're going up. If you were going up and you're going down, that's what I meant. If you're going up, now you're going down. Okay. 0 right to 5 right. So 0 right to 5 right. If you were going right, you're going left. So right to left. If you're going 1 right to 5 top, then that means going right means going down. So right to down is a +1. That's a +1 and a -1. And then 2 left to 4 bottom, 2 left to 4 bottom. So if you were going left, now you're going up. So if you're going left, now you're going up. So that's a +1 and a -1. +1 and a -1. And then if you're going 2 bottom to 3 bottom, 2 bottom to 3 bottom, so you're going down and now you're going up. So that's just inverted. And 3 left to 5 bottom. So 3 left to 5 bottom. So if you were going left, now you're going up. So if you were going left, now you're going up. So that's +1, -1. 3 left to 5. So that's +1, and then that's -1. Okay, so the move is direction change. Var direction change is 0. And this would be direction change, right? Then this would be direction change. We might be marking the wrong direction character, unless we take the direction change into account right now. Actually, we don't need to return the direction change. Then we can say direction plus equals direction change here, because we only do it if we're actually changing, right? Because if we moved, then we care. Direction plus equals change, direction change. If direction is less than 0, then direction plus equals 4. Else if direction is greater than 3, then direction minus equals 4. All right, and then we just return result x, result y. Okay, now we'll watch it move. Okay, now let's compare this to what we have over here, which is our whole path, right? So we've got right, right, stuck, 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 stuck. Actually, we can really shortcut that, because if you're blocked, right? So if you're blocked, yeah, but we only do that with move though, right? So, all right, whatever. I'll walk through it. It's fine. It's not that much. Okay, come back here. Come back here. Come on. Okay. So this is what it's supposed to look like down here. Okay, so we got right, blocked, 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 down, 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 down. Returning right. We're going to move 5 spaces to the right. So we've got right, right. Well, we recorded it as a down, but it's really a right. I can fix that. That just means we recorded it incorrectly at the incorrect time. This is fine, right? Okay. There we go. Come on back here. There we go. Okay. And then we're blocked. We move down 5. We're turning right. We're going to 1, 2, 3, 4. And now we're blocked. Now we're turning left. 10 spaces. So 1, 2, 3, 4, and then a bunch of blocked. Now we're down 4 spaces. So 1, 2, and then we're over there. And now we're heading up. Now we moved up. And we're going right. 1, 2, 3, 4, 5. Now we're going up, which is up and up. And we're just blocked, and that should be the end. And the answer is 5031. The answer is 5031. Holy smokes. Okay. So that was correct. So we're all good there. So now all I have to do is I have to replace, I don't actually need the side size at all. I just need the empty maps to be correct. Okay. So if false, else, and if. Now, I need the correct data here. I need you to be big so I can actually get a visualization of you, right? So you start at 51 and you go to 150. So that's 2 sides. Okay. So now we gotta draw again. Okay. So I need a small one. So we can have 2 sides. So this is a side. This is a side. And then we've got a side that comes down here. So that's 51 to 100. So that's just one side there. All right. And then we've got looks like side, side, side. So side, side, side. Okay, so we're gonna do this as 1, 2, 3, 4, 5, 6. All right, now let's draw bigger ones. Yeah, damn it, I drew it wrong. It's okay. We'll draw it on the other side. Got more space on the other side anyway. Okay. So draw it like this. So let's do, gotta go 3 across and 4 up. So let's do it like this. 1, 2, 3, 4, 5, 6. So you're 1, 2, 3, 4, 5, 6. Okay. Okay, time to cut it out so I can fold it, so I can visualize it, because that's the only way this is going to work for me. Okay. Let's make our folds. All right, here's our new cube. Okay. So, given this, right, we know that this is 50, right? 50 comma 0. And so then this is 99 comma 0. This is 100 comma 0, and this is 149 comma 0. So this would be 50, 49, and this would be 99, 49. This would be 149, and then this would be 149, 49. This is now 50, 50, 50, 99, 50, 100, 50, 149. This is a 99, 50. This is 99, 99. This is 99, 100. This is 99, 149. So this is 0, 100. 49, 100. This is 0, 149. And this is 49, 149. This is 0, 150. This is 0, 199. This is 49. Oh, sorry, this is a 50, 50, 149. And then this is, wait a minute, I did that wrong, didn't I? This is 49, 150. 49, 199. All right, make sure all my numbers are right. 50, 0, 99, 0, 100, 0, 149, 0, 50, 49, 99, 49, 149, 149, 49, 50, 50, 99, 50, 50, 99, so 50, 50, 50, 50, 50. 49, 49, 49, 49, 0, 0, 0, 99, 99, 99, 99, 99, 99, 100, 100, 149, 149. 0, 0, 0, 0, 49, 49, 49, 49, 50, 50, 99, 99, 100, 100, 100, 100, 149, 149, 149, 149, 150, 150, 199, 199. Okay, so then this would be 50, negative 1. This would be 99, negative 1. This is going to be 100, negative 1. This is going to be 149, negative 1. This is going to be 150, 0, 150, 49, 149, 50.
150, 199, and then 100, 100, 100, 149, 99, 150, 50, 150, and then 50, 199, 49, 200, 0, 200. See, so 49, 0, 49, 49, 49, 50, 49, 99, and then 0, 99, and negative 1, 100, negative 1, 149, negative 1, 150, negative 1, 199. That is every off edge, right? Okay. I need a quick bio break, so I will be right back. Okay, I'm back. Let's see what we've got here. We've got well, here's our stuff. All right, 1, 2, 3, 4, 5, 6. This is our stuff. Get this cube out of here so we don't accidentally use it. Okay, so we've got, I'm just going to start right down all the sides here. We've got one top, to 6 left. So up to right. Okay. So now I've got 1 left. One left to, looks like 5 left. Right, so that would be a left, converts into a right. And then I've got 2 top, 2 top goes to 6 bottom. And so if you were going up, then you are now still going up. Yeah. Okay. So then I've also got 2 right, 2 right, 2 right to 4 right. And so if you were going right, then that means you're now going left. So then we've also got 2 bottom. 2 bottom to 3 right. So if you were going down, you're now going left. Okay, so we've got 3 right already, so what we need is 3 left. 3 left to 5 top. And you're going left. That converts into down. And then, so we got 3 left and right. We've got 4 right already, right? We do not have 4 bottom, so 4 bottom to 6 right. So you are going down, you're going to be going left. So there's 4 right, 4 bottom. We've got 5 top already. We've got 5 left already. We've got 6 left. We've got 6 right. We've got 6 bottom. So that's all of them. Okay. I is equal to 0. Since these are all the exact same loop, we can actually put them all up in here. Right? There should be 6 intersections. There are, so 1 top to 6 left. 1 top to 6 left. All right, so coming off the top of 1, that's going to be empty space maps. So coming off the top of 1, that is 50 to 99, so 50 plus I. Oh yeah, these go to 50. Now they don't go to 4. So 50 plus I to negative 1. Those 1 top to 6 left. 1 top to 6 left, and they're forward, so that would be 6 left would be 0, 150 plus I. And then we need a direction change from up to right. So where's our direction lists again? So up to right is +1, right? And then we're going to do 6 left, which is going to be -1, 150 plus I is equal to 1 on the top. So those are going forward. So that's going to be 50 plus I, 0. And of course, you go backwards. So 1 left is going to be 49, I. So 1 left maps to 5 left in reverse. So 5 left in reverse would be 0 and then 149 minus I. And left to right is a flip of 2. And so now if we come off of the left of 5, then that would be -1, 100 plus I. It's going to be equal to 1 left in reverse, right? So 5 coming off the left is 1 left in reverse. So that would be 50, 49 minus I. And your direction change is 2. All right, 2 top to 6 bottom. So 2 top would be would be 100 plus I comma -1, and 6 bottom. So 2 top to 6 bottom. Yeah, that's a straight up map. So 6 bottom would be I comma 199, and you don't have a direction change. All right, same thing here. So if we come off the bottom of 6, it'll be I comma 200. And then you're going to go to the top of 2, so that's 100 plus I comma 0 with no direction change. All right, come off the right here. This will be, come off the right of 2 will be 150 comma I. And the right of 2 hits the right of 4 in reverse. So that'll be 100 comma 149 minus I. And your direction change from right to left. Okay, and then coming off the right of 4 is going to be 100 comma 100 plus I. It's going to be equal to the right-hand side of 2 in reverse. So that will be 149 comma 49 minus I, and direction change. Okay, so coming off of the bottom of 2 will be 100 plus I comma 50, and you get mapped to 3 right, so 2 bottom to 3 right. 2 bottom to 3 right. That is a straight match. So 3 right would be 99, 50 plus I. And then a down to left, down to left is +1. All right, and then the opposite direction, 3 right would be 100 comma 50 plus I. Gets mapped to 2 bottom. All right, gets mapped to 2 bottom, so that's 100 plus I comma 49, and the opposite change direction, and then we got empty space maps. 3 left, so that'll be 150 plus I is going to map to 5 top. 3 left maps to 5 top, and that is forward, so that is I 100, and your direction change from left to down is a -1. So empty space maps of, all right, now 5 top. 5 top is 0, no, is I comma 99. You get mapped to 3 left, which is in order, right? So 3 left, which is in order. So that's 50 and 50 plus I. And we go the other direction. And then finally, 4 on the bottom. 4 on the bottom is 50, let's see, 50 plus I comma 150 maps to 6 on the right. So 4 on the bottom maps 6 on the right, and that is a linear map. That is forward map, I should say. So 6 on the right gets 49 comma 150 plus I, and then down becomes left. Down becomes left as a +1. And then finally, 6 right. So that is a 50 comma 150 plus I gets mapped to 6 right, gets mapped to 4 bottom. So that is a 50 plus I comma 149, and you go any other direction. Okay. In theory, that's everything, right? That's everything. Except we're not going to print anything out anymore because that's just going to take too long. We're just going to run you. Index outside of the array. Why? Why would that be? So we've got a result X of 140, a result Y. Okay. That doesn't make sense. So we came in here at 149 and 6. So 149 and 6 is along the top of 2, which means we must be going up, right? So no, we're going right. Wait a minute. 149 and 6. Can I just rewind? I can probably just rewind, right? I can just rewind. Okay. 149 and 6. So 149 and 6. So the direction is right, which means we should be 150 and 6. So we've got an empty space map for 150 and 6, which puts us at 100 and 143 with a direction change. So 150 and 6. So that's off of 2. 2 off the right. So that's going to be mapped to 4 right. So 150 and 6 maps to 2 right, maps to 4 right in reverse. So 2 right is 150 comma I goes to 4 right. That shouldn't be 100, that should be 99. And then it's 149 minus I. Okay, now I'm going to double check all of these. All right, so 1 top to 6 left. 1 top to 6 left. That is a forward match. So 1 top is 50, -1. So 6 left would be 0 and then 150 plus. Okay, so then 6 left would be -1, 150 plus I would map to 1 top, so that would be 50 plus I, 0. Okay, good. Okay, so 1 left maps to 5 left in reverse. So that's 49 comma I maps to 4 left, maps to, I'm sorry, 5 left in reverse. So that would be 0 and 149 minus I. Okay, so then off of 5 left, excuse me, off of 5 left, so 5 left is -1 comma 100 plus I, right? Maps to 1 left in reverse. So that would be 50, 49 minus I. Okay, good. Yeah, let's just run it. Nope, still no good. Okay, 2 top to 6 bottom. 2 top would be 100 plus I minus 1. That goes to 6 bottom. That is a linear map. So that's that's I comma 199. Okay, good. And then coming off the bottom of this would be I comma 200. Goes back up to 2 top in a linear fashion. So that would be 100 plus I comma 0. And it is. And up goes up. Okay, 2 right. So that's 150 comma I. Yep. And that's going to go to 4 right. So 2 right to 4 right. That's inverted. So 2 right to 4 right. So that should be 99 comma 149 minus I. 99, 149 minus I. And then coming off of this is 100 comma 100 plus I. Yep. And then that's going to 2 right inverted. So that'd be 149 and that would be 49 minus I. Okay, good. 2 bottom. 2 bottom to 3 right. Yes. And that gets mapped linearly. So 100 plus I comma 50. Yeah. And then 3 right. That would be 99 comma 50 plus I. Yep. Okay, good. And then we've got 100 comma 50 plus I. Yep. And then that goes into 2 bottom, which is 100 plus I comma 50. Or 49, sorry. 100 plus I comma 49. Right? So these should all be divisible by 50 if they're added. Actually, one left. Right, divisible by 50 if they're added, otherwise they should be a mod, they should be one off. So divisible by 50, one off, divisible by 50, one off, divisible by 50, one off, divisible by 50, this 200 is 6 bottom. Yep, that's right. All right, where was I? I was on 2 bottom and 3 right, right? All right, 2 bottom is 100 plus I comma 50, and then 3 right. This is a linear, this is a forward map. So that's 99 comma 50 plus I. Yep. And then coming off of 3 right, that's 100 comma 50 plus I. And then going up there, that's 100 plus I comma 49. It is. Okay, so 3 left to 5 top. That is a forward map. So 3 left. This is wrong. This is definitely wrong. 3 left. This is supposed to be 3 left. Yeah, this is what's wrong here, right? So 3 left is 49 comma 50 plus I. And that gets mapped to 5 top in a linear fashion. So that's I comma 100. And then coming off of this 5 top, that would be I comma 99. And then this goes to 3 left, which is going to be 50 comma I plus 50. Okay, so that was wrong. Okay, I'm glad we found something wrong. All right, so coming off of 4 bottom, that would be 50 plus I comma 150. It is. That goes to 6 right, and that is a forward match. So that's going to be 49 comma 150 plus I. It is. And then coming off of that one, it's going to be 50, comma 150 plus I, it is. And then that goes to 4 bottom, which is going to be 50 plus I, comma 149, it is. Okay, please give me an answer. Why do you have an index out of array? Back here, please. Back here, please, actually. So result X is position X. So we're at 0, 85, and our direction is left. We're at 0, 85. How did we get to 0, 85? We shouldn't be able to be there. Yeah, we shouldn't be able to be there. If map at position Y, position X is equal to a space, or map at result, sorry. This is what I want. I need an assert here, right? Throw new invalid operation, right? Set a breakpoint here. You should never come off the board. How did we come off the board? 34.98. Oh, actually, we need to do result X, result Y, result X. But also, yes, how did we come off the board? Okay, so at 50, 52. So at 50, 52, we're in 3, right? We're in 3. We're going left. So you cannot get to 49.52. That should have bumped out with 3 left. So where's our 3 left mapping? Where's our 3 left mapping? 3 left to 5 top. Okay, so 3 left is 49, comma 50 plus, oh my God, this is plus 1 instead of plus I. Wow. Wow, that's gonna be what it is, isn't it? 134170. 134170, 134170. And that's the right answer. Yeah, I I have to say that I hated this problem a lot. Not because the logic was difficult, although the logic was pretty annoying at times. But because I really didn't know how to take the generalized input and automatically construct all of these things. I literally was cutting out pieces of paper, right, and folding them up. There's my 1, 2, 3, 4, 5, 6, and I was writing graphs like this, where I was putting all the coordinates in all the corners so that I could say, hey, you know, if you come off the left edge, for example, that's 49 to 0 through 49. Which, you know, there's a way to do this that I just don't know, but the amount of, you know, it's like I did my Google and I couldn't find it. So the amount of time it would have taken me to find what the correct algorithm is, not knowing what the correct algorithm is, not knowing what to search for, I was kind of screwed, right? I mean, that's all there was to it. So I had to do this hard-coded. So my solution obviously only works for my data. If your data looks different, then you would have to come through and draw this cube and figure this out yourself, unless you knew the real algorithm. So, well, anyway, it's day 22. It's in the bag. It was a long one. At least it's done. So I'll see you tomorrow.